So this is the review. If you guys forgot it at home or something like that, you're going to have to do this on scratch paper, which is okay. However, remember this is due on the day of the test. All right, we'll show all our work and we'll write our answer in the spaces provided. And we'll use full sentences when necessary. John bought a sandwich for $3 and 4 candy bars. He spent a total of $5.20. What is the equation for this problem? All right, the equation has to do with the two things that he bought, which would have been the candy bars and the sandwich. So, start this off, right? He purchased a sandwich for $3. But then in addition to that, he bought 4 candy bars. And then this would equal the total that he spent. So I'm just going to go ahead and replace these values in the equation as we have it written, which is kind of just to help us set it up. So the sandwich was $3, so I'm going to replace that with $3 there. And the candy bars, we don't know how much each candy bar is. So in our equation, we need to define that for x. So x will be the price for each candy bar. Well, what we know right now is that he bought 4 of them. So there'd be 4 times the price for each candy bar would tell us how much John spent on candy bars. This equals the total, which was $5.20. And this will be the equation for us right now. All right, so I'm going to write that in the space provided right there. Bam. All right, now what we need to do is figure out how much each candy bar costs, which is the same thing as solving for x in this one. So regularly on equations, what we would do is distribute if it was necessary, and then combine like terms. But that's already done on both sides of the equation for this one. So I'm going to just focus on principles of equality to isolate my x's on this one. Which means I don't want that plus 3 with the 4x. So I'm going to subtract 3 from both sides of this equation. So that drops my 4x there. And that zeroes out the 3's. So $5.20 minus $3 would be $2.20. Now just in context right here, we can tell that on the 4 candy bars, John spent $2.20. But we don't want to know how much he spent on the 4 candy bars. We want it to be 1 candy bar. So we're going to divide both sides by 4. So that gives me 1x, which is what we want, and $2.20 divided by 4 would be 0.55. We got to be careful with how we write this as the answer though, because some of you guys know that's 55 cents, but if you write it as 0.55 cents, it's going to be marked wrong. It's not 0.55 cents, it'd be $0.55 on this one. So we have both the equation and the answer written in this one. Actually, you guys take a minute and do number 2. Just talk about it with your neighbor and see what you did. So this equation is set up almost exactly like the equation did on number 1. So to solve this one, we want to isolate the x's, which means I don't want that plus 14 there. I'm going to zero that out by subtracting 14. But as a principle of equality, it's a subtraction principle of equality, which will zero out that plus 14 right there. So I've subtracted 14 from both sides of the equation. I'll drop this 8x. And 32 minus 14 is 18. But I don't want 8x's, I want 1x. So I've got to change that 8 into a 1 by dividing both sides of this equation by 8. So 8 divided by 8 is 1. That gives me 1x equals 18/8, which I will simplify by dividing both of those by 2. But your calculator will do that work for you. That'll come out as 9/4. Alright, we're not finished with this problem yet either. So I've got to go to the original equation, 8x plus 14 equals 32. And I'm going to replace the x value. So this is something you'd put into the calculator as well, and we're just testing to see if this is true or not. So 8 times 9/4, that would be 18, plus 14 would be 32. So 32 does equal 32. That's true. Since it is true, we know that this answer is a solution to that equation. Number 3, solve the following linear equation for x. This one's the same idea, except there's x's now on both sides of the equal sign. However, there's no distribution on this one. So I'm going to look first to combine my like terms on either side of the equal sign. So I'm just focusing on one side and then the other side. So I've got those 12x's plus those 3x's, which would combine to be 15x's. And then we got this negative 11 right there. On the right side, I've got 13 and negative 4, which would combine to be a positive 9. And then I've still got this positive x, which I'll have out in the front. So I've got 15x minus 11 equals x plus 9. And this sets up the equation for us to use principles of equality. And before I do that, I'm going to choose which side I want the x's on, which for me is going to be on the left side. And I will put numbers on the right side. But it wouldn't matter which side you chose for either. To solve this, I've got that negative 11 on the left side of the equal sign, which I don't want there because it's on the x's side. So I'm going to have to zero that out by adding 11. But as a principle of equality, I'll have to add it to both sides of the equal sign. So that zeroes out, which is what we wanted. I'll drop that 15x. Then this equals, I'll drop the x here as well. 9 plus 11 would be positive 20. Well, I've got that x on the right side of the equal sign, which we don't want. So I'm going to have to zero that out as well. And right now we can see it as a 1x if it helps. So I'm going to subtract it from itself. 1x minus 1x, that zeroes out, which is what we wanted. 15x's minus 1x would be 14x's. And then this equals 20. So I don't want 14x's. What I really want would be 1x. So I'm going to change that 14 into a 1 by dividing it by itself. 14 divided by 14 is 1. So 1x equals 20/14, and I can simplify that by dividing both of these by 2, which your calculator will do for you again. And I don't really expect you guys to show that step because I do want you guys to do that in the calculator. And that would be 10/7. But we're still not finished. What we need to do is take the original equation, and I'm going to go into that original equation and replace all the x's with that 10/7. Now right now I don't know if that's equal, but I put it in the calculator to find out. So I get 73/7 on the left, and on the right side, still 73/7. So this is true, and since it is true, I know that the answer that I have for x is a solution for this equation. So I'll write that in, x equals 10/7. You guys take 1 minute and solve this one. Let's go ahead and solve this one then. Now this one does have distribution, but there's only t's on one side of the equal sign, which is good. So I'm going to take this, this would be negative 3 that I'm distributing into the set of parentheses. So that would be negative 3 multiplied by the 2 t's, or negative 3 sets of 2 t's would give me negative 6 t's. And then I've also got negative 3 sets of negative 4 because it's going to keep this operation to its left. That would be positive 12 right there. So I've got 7 minus 6t plus 12 equals 25 because I've distributed that, which gets rid of the parentheses, which is what we want. And now I have one full expression with no distribution, but I do need to combine like terms now. So I'm going to look to combine the 7 and the 12, which would combine to a positive 19. Of course, I still got that negative 6t. Negative 6t plus 19 equals 25. Now my t's are already on the left, so I'll keep them there. But I don't want that plus 19 with it, because I've got to isolate those t's. So I'll use the subtraction principle of equality to zero that out. And if I do it to one side, I must do it to the other side as well. That zeros that. So I'm going to drop that negative 6t. And then this equals 25 minus 19 is positive 6. Last thing I need is a 1t, not negative 6t's. So I will divide both sides by negative 6, which is the division property of equality. Negative 6 divided by negative 6 is 1. 1t equals, that would be negative 1 now. And that is that I need to rewrite this equation just as it was in the beginning. And I'm going to replace the t value in that equation with the t value we found, which was negative 1. And we'll see if this is true. So the right side's already solved for us, that's nice. But 2 times negative 1, that's negative 2, minus 4 is negative 6, times negative 3 is negative 18. That'd be 18 positive rather. So 7 plus 18 is 25. So that's true. Since this is true, we know that the answer we found for t is a solution to the equation. Number 5. On Tuesday, 258 students went on a field trip to the museum. All 6 buses were filled and 12 students had to ride in a van. How many students were in each bus? I take a minute and compare your answers for this one with your neighbors. Alright, let's look at what's happening on this problem. So we've got 6 buses and we've got 1 van. So when I add the people in those vehicles together, then I get total number of people, or students, that went on this field trip to the museum. Now right now, we're actually solving for how many people are in the buses, so I'm going to define x as the number of students in each bus, which means if I figured out how many people were just in the buses, then I would have 6 buses multiplied by the number of people in each one bus. So that's 6x. In the van, actually there was only 1 van, so we'll just make that van. And I got 12 students riding in that 1 van. This gave me a total of how many students went on the field trip, which was 258 students. So when I add the 6 buses with the van, I should get 258 students. This is the equation, which we will now solve. So I've got my 6 buses. If I subtract 12 people from the total number of students, then I figure out how many people were in the 6 buses, which appears to be 246, because those 12 zero out. Last thing we would do to solve this one is to divide both sides by 6 buses, and x will represent, looks like 41. Now be careful, if you leave the answer as this 41, you're going to lose at least 1 point. It's actually 41 students in each bus. Alright, so with these word problems especially, we need labels on those. We could check the answer on number 5, but we kind of have to make an assumption that the equation that we wrote was correct. And if we do replace x with 41, we get 258 equals 258, which is true. So it checks off for our equation at least. First thing I'm going to do on this one is to distribute that negative 4. So this would give us negative 4 sets of A, which would be negative 4 A's. And then I've got negative 4 sets of negative 5, which combine to be a positive 20 right there. So I've got negative 4A plus 20 plus these 2A's equals on the other side A plus 22. There was nothing I could simplify on the right side of the equal sign because there are no like terms. However, there are like terms on the left side. So I can combine this negative 4A with that positive 2A, which would combine to be negative 2A's. So I've got 20 minus 2A equals this A plus 22. And I'm going to put the A's, we'll just keep putting them on the left. So I've got A's on the left, numbers on the right. Which means that 20, that positive 20, is not on the right side of the equal sign, or the correct side, so I've got to subtract 20. Not only from that side of the equation, but the other side as well, to maintain equality. So I'm dropping this negative 2A, which will equal A, and 22 minus 20 is a positive 2. Next up, I've got that 1a on the right side, but it's on the numbers side of the equal sign, so I'm going to have to get rid of it by subtracting the 1a from both sides of the equation. And negative 2a's minus another 1a would give us negative 3a's. And then we'll drop this 2 here. Finally, we don't want negative 3a's, we want just 1a. So I'm going to divide both sides by negative 3, which gives us an answer of 1a equals a negative 2/3. But we should check still, so let's write the equation again. And we're just going to go ahead and replace all the a values in the original equation with that negative 2/3. So we're not sure if this is equal yet, but we're going to find out. So on the left side, I'm just going to plug that into a calculator and see what I get. And then on the right side, I also get another 64/3. Since this is true, I know that the answer that I had for a is a solution to the equation originally. Alright, number 7 is not asking for the solution to the equation. It's asking how many solutions does the equation have. So I do want to split this up into two separate expressions, and I'm going to start combining like terms. For example, I've got this 5x and this negative 3x, which would combine to be positive 2x's. Then I've got this positive 2 still. On the right side, I've got my x's, 4x's, this negative x, or negative 1x, and this other negative 1x, which would combine to be positive 2x's. And then I'll also combine my numbers. 19 and positive 2 would combine to be a positive 21. So these two are equal, and we'll determine what the value of x is, even though some of you would know what the answer is at this point. That's okay. We'll talk about that in a moment. So we're using principles of equality at this point, and I'm going to put my x's on the left side of the equal sign, number side on the right, which means this plus 2 in black there, I need to get rid of it by subtracting 2 from both sides of the equal sign to zero that out. And 21 minus 2 is, that'd be positive 19 right there. So I'll drop these two x's, and we'll say these two are equal for now. Then finally, I've got these two x's on the right side, which I don't want. And again, this step it may be enough for some of you guys to know what the answer is. I'm going to subtract two x's though, to put all my x's on one side of the equal sign. 2x's minus 2x's leaves me with 0 x's there. This one cancels away as a phantom 0. And this equals this 19 right there. So then it becomes a question of what can I multiply by 0 to get 19? There is nothing. So this one has no solutions. So how many solutions does this problem have? None. Number 8, in the equation shown, what is the value of x that makes this equation true? Alright, so we do have some fractions on this, and it's really just asking us to solve this equation. Alright, so just like we would with any equation, even if it has fractions like this one, I'm going to distribute this 4/3 into the parentheses. So 4/3 times x would just give me 4/3 x. But then I've got 4/3 multiplied by negative 6, which would be a negative 8 right there. You can use a calculator to check that. Just have the rest of this stuff. That's a positive 4/3 x, so we've got plus right there. Alright, we could combine like terms in this on the right side for now. So 20 minus 8 would be positive 12. Now I'll choose, I'm going to put the x's on the left side again and numbers on the right side just to remain consistent. Which means that minus 8 is on the wrong side of the equal sign. I'm going to have to add 8 to both sides here. And 12 plus 8 is 20. It's positive, and then that 8 right there canceled away. But I've got that 4/3 x on the right side of the equal sign, which we don't want, because it's on the wrong side of the equal sign. So I'm going to have to subtract it from both sides to zero it out. And the nice thing about this one is it gave us common denominators already. Of course, this part zeroes out. 1/3 x minus 4/3 x's would give me negative 3/3 x's. And this is still equal to this 20 here. So we'll drop that down. And I'm going to change that negative 3/3 x into a negative 1x. Well, finally, we don't want negative 1x's, we want positive 1x's, so I'm going to divide both sides by negative 1 to make the coefficient of x a positive 1. 1x equals negative 20. Of course, we can't be sure until we check this thing, so I'm going to rewrite the original equation. And in this original equation, we're going to go back and replace the x's with the x value we think it is, which is negative 20 right now. And we'll plug this into the calculator to see if this is true or not. Got negative 44/3 on the left and on the right. So it looks like this is true, which means that our answer is true, or that the x value is negative 20 makes our original equation a true statement, which means it is a solution to that equation. This problem has two parts for the triangle shown, and they've only given us the outside lengths, which is good. No need to deal with the angles on this. Write an equation that represents the perimeter of the triangle. Now, if we didn't know the perimeter, then it would be the perimeter equals the three lengths added together. So I'm just going to plug these in. I've got that 4x, I've got the 5x, and also the 27. So I would say this is the equation for the perimeter of the triangle. Okay, so that's the equation for this perimeter. Let's go and copy that down, but we need to replace the perimeter on part B with this 99 that it gave us as the perimeter. Alright, so this is our new equation, which we can solve to find the value of x. That's all it wants, not the side lengths. So I'm going to go into this and combine the like terms on the right side, which would be the 4x and the 5x, which combine into 9x. Of course, we still got the plus the 27. This equals 99. Then we will subtract the 27 from both sides to isolate the x's. So I've got 9x's equals 72. Then finally we'll divide both sides by 9 so that we get 1x right there, and we see that our 1x is 8. That's all they wanted us to do. Of course, we can check. 4 times 8 plus 5 times 8, that would be 72, plus the 27 is 99. So that checks off. And we know that that value of x gives us a true statement. X is 8. What is the solution for this equation? Alright, well, let's find out. So I'm going to split this up again on two different sides of the equal sign, and I'm going to start combining like terms. So the negative 15x and the positive 3x would give us a negative 12x's. And then on the right side I've got that 9 and negative 2, which combine to be a positive 7. So I've got that negative 12x plus the 2 there. This will equal, we'll say, negative 3x plus 7. So we simplified both sides of the equal sign, which then allows us to choose sides for x. I'm going to put x's on the left, numbers on the right, which means that plus 2 is on the wrong side of the equal sign. So I'm going to have to subtract 2 from both sides to zero that out. We'll drop this negative 12x equals these negative 3x's. But 7 minus 2 would give us a positive 5 there. But then I've got the negative 3x on the wrong side of the equal sign, so I'm going to have to add 3x's to zero that out. But I've got to do it to the other side as well. Negative 12x's plus 3x's would be negative 9x's. And then this equals this 5. Once again, we want the coefficient of x to be 1, so I'm going to divide that negative 9 by itself on both sides of the equation. Negative 9 divided by negative 9 is 1. 1x equals negative 5/9. But we will check this one. And let's go ahead and replace the x's with the value of x that we think it is. Right now that's negative 5/9. Alright, now again, we don't know if this is correct. We'll see. I'm just going to plug this into a calculator and see what I get. So I got negative 14/3 on the left. If I do it to the right side as well, alright, I take that back. I got 12 after putting it in my calculator. And then what about the right side? Wait a sec, I think I plugged that in wrong again. There we go. So I plugged it into the calculator wrong, but after checking again, I got 26/3. Then 9 minus 3 times negative 5/9 minus 2. It also is 26/3, so that's true. And since it is true, we know that this is the answer for that solution. X equals negative 5/9. Alright, we got two parts for 11. Write an equation for the sentence below. Use x for the unknown. The difference between negative 7 times the number and negative 14 is negative 35. So again, you may have to read these several times in order to figure these out. In any case, it is a difference, which is subtraction. So we'll just write that in for now. What is it the difference between negative 7 times the number? So we'll write that in. Negative 7 times the number, which we don't know, so we'll just say it's x. And 14. So that's our other part of that. It's a negative 14 actually. Then this is, so equals negative 35. So that's the equation for it. I'm actually going to change this to plus right here because it's minus a negative. And that sets up the equation for us. So, going over the same technique we've been doing, we're going to subtract 14 from both sides. The subtraction property of equality zeroes that out. And I've got negative 7x equals negative 49. Then we'll divide both sides by negative 7 to make that coefficient of x a 1. Negative 7 divided by negative 7 is 1. And negative 49 divided by negative 7 is positive 7. Now again, we could check this one. This one won't be too bad. Negative 7 times 7 is negative 49, which is what we expected. Plus 14 is a negative 35. So x is negative 7 is the solution. Number 12. A game rental company charges $4.75 plus $2.25 a day for renting a game. Jim paid $29.50 to rent a game. How many days did he pay to have the game checked out? Alright, here's what we know, is that there's some kind of fee there in the beginning that Jim has to pay. Plus he has to pay however much it costs per day. And when we add those two together, we get the total amount that Jim paid. And we will define our variable in this case, which would be x. How many days did he have the game checked out? So that's going to be the number of days he had the game. And let's start filling in these values. There was some kind of initial charge, which is the fee, at $4.75. In addition to that, he had the game for some number of days, which we don't know right now. But we do know that it costed $2.25 per day. So we'll multiply those two together. And this equals the total amount that he paid, which says it was $29.50. And this sets up the equation for us, which we can then solve. So to start out, we'll subtract $4.75 from both sides of the equation. And this isolates our x's for us, so $2.25 per day equals, looks like $24.75 right there. So in other words, just for the amount of days he had it, he paid $24.75. Last thing we'll need to do on this one is divide both sides by 225 to make that a 1x. But I've got to do it to both sides of the equation. Plugging this into my calculator, looks like it's 11. Now be careful because the answer is not 11. We need to label this as 11 days. And again, we could check that 225 times 11 plus the 475 is 2950. So that confirms, just based on the equation that we wrote, so as long as we wrote that correctly, that this would be the right answer. How many solutions does the equation have? This means that we do not have to solve it, we just have to figure out how many solutions it has. So let's take a closer look at this. So if we look at the options on this thing, it appears that it's not no solutions, one or two solutions. Anything multiplied by 0 is 0, which means that the answer is D on this one, infinite solutions. So let's look back, right? We simplified by combining all our x's on both sides and the numbers where we could. So I've got 16x minus 2 equals 16x minus 2. That already is a true statement, but again, if we continue the process to solve that equation, we get 0x equals 0, and anything multiplied by 0 is 0. So if I said x is 1, that's true. If I said x is 2, that's true. If I said x is negative 50, that's still true. So I have an infinite number of values that I can replace for x in the original equation that would give me true statement. That's infinite solutions. All right, so let's look at this, solving that, because it looks like we're not really fully understanding why that has infinite solutions at that point. So for this equation, I'm going to put my x's on the left, numbers on the right, which means that 16x is good, but I've got to add 2 to both sides of this equation, which gives me 16x, that zeroes away, equals 16x plus 0. Because that's negative 2 plus 2 right there. That's 16x. But that 16x on the right is on the wrong side of the equal sign, so I'm going to subtract 16x from both sides. That zeroes that away, and I make it a phantom 0, but I'll drop this one. 16x's minus 16x's is 0x's. So again, this question is, what value multiplied by 0 right here is 0? Any value is, which means there's an infinite number of solutions that would make that equation true. Number 14 has 3 parts, and it's just asking how many solutions each one of these equations has. So we'll simplify each of these again. I've got 4m times negative 3, which is 4m minus 12. This should equal, let's see, I'd have 10m. Negative 6 times m is negative 6m. And negative 6 times 2 would be negative 12. Further simplifying this, I'd have 4m minus 12, nothing to simplify on the left. But 10m minus 6m would be 4m. And then we still got that minus 12 there. So once again, we don't need to go any further because we can see that the left side is equal to the right side. It's the same expression, which means this one has infinite solutions. So if we were to explain this, I would say that the coefficients of m are the same on both sides of the equal sign, and they're subtracting 12 from both sides. So it's the same expression on both sides of the equation. Next up, part B, I'm going to distribute this negative 2 into the parentheses. Negative 2 times negative 3 is a positive 6. Negative 2 times negative 5x is positive 10x. And then I'll distribute this 5 into the parentheses. 5 times 1 is 5. Positive. 5 times negative x would be negative 5x's. And then on the right side, I've got negative 3 times x, which is negative 3x. And then negative 3 times 2, which is negative 6. Of course, we still have the rest of that equation. And we'll just simplify this a little bit further. Combining like terms, I've got 6, 6, 4, and 5, which appears to be 21 positive. Then I've also got this 10x and the negative 5x, which would be a positive 5x. Now let's compare this to the right side, which I've got 7x's minus 3x's, which is 4x. And then also negative 1 minus 6 minus 4, which is negative 11. There's no need to continue on this one, because I have a different number of x's on the left than I do on the right, which means if I continued, I would not get 0x. So this one automatically has one solution. No need to solve it. It just wanted to know how many solutions there are. One solution in this case. So again, the coefficient is the number that the x is being multiplied by. And I guess we can mention that they're on opposite sides of the equal sign too, I guess. There we go. So that explains why this one has only one solution. On both sides of the equal sign, there's different coefficients of x's after it's been simplified as well. So let's go ahead and simplify this. And we'll start by distributing the 2 into this set of parentheses on the left side of the equal sign. So that's 2 times 3a. 2 sets of 3a's would give us 6a's. Let's put x there. And then 2 sets of 12 would give us positive 24. Now we can distribute this 3. 3 sets of 2a's would be 6a's. And 3 sets of negative 8 would be negative 24. Of course, we're saying that these two are equal. Now we don't need to go any further because we know right now that these are not equal because I've got 6a's there and 6a's there on either side of the equal sign. But we're adding different things. On the left we're adding 24. On the right side we are subtracting 24. So even though we have the same number of a's on either side of this, we're adding different things. Let's take this actually, and we'll continue solving this just in case we didn't notice that, which is okay. Alright then, I'm going to put my a's on the left, numbers on the right, and I've got 6a on the left already, so I got to get rid of that plus 24 by subtracting 24 from both sides. So we'll drop that 6a. This equals, that zeroed out right there. I'll drop this 6a as well. Negative 24 minus 24 is negative 48. Then I've got these 6a's which I've got, it's on the wrong side of the equal sign. So I will subtract those 6a's, that's just going to zero out. And I've got 6a's minus 6a's which gives me 0a's left over. And I've still got this negative 48. Well, a times 0 equals negative 48 is asking what number times 0 is negative 48. Well, there's nothing I can multiply by 0 that would not be 0. Therefore, this one has none solutions. And that's the answer we want on part C. When the coefficient of the variable or unknown is 0, then we've got to look at what it equals. So, again, if I had something like 5x equals 0, this one is still solvable because the coefficient of x is 5. I can find a number times 5 to be 0, and I would know that x is 0. These two are very different, so be very careful with where that 0 value is. (15a) says write an equation that has no solutions, and then we'll explain. And then we'll, for 15b, write one that has one solution, and C for infinite solutions. We'll explain these as well. So if I wanted no solutions, then just based on the equal sign, and we do need equals on all these, I need the same number of x's on both sides of the equal sign. So we'll say 4 x's. But if it has no solutions, I need to add different things, such as 1 and maybe 7. Or, yeah, sure, 17 would work. It's still adding something different, which makes this have no solution. So 4 times x, no matter which side you're on, is going to give you the same value, but we're adding something different and saying then that they're equal. That can never happen. So there's our explanation for this one. 15c will be very similar, but there will be a slight change in the sentence. So 15b, we want one solution on this. All we need for one solution is to take the x's, like these ones, and we need different coefficients of x, such as 1 and, 6. Now from here it doesn't matter what we add or subtract, so I could subtract 2 or add 15. It wouldn't matter Because the coefficients of x are different on either side of the equal sign, automatically there will be only one solution. Now we could look at that 15a if we were to continue solving that. We'd eventually get 0 x's. On 15b we won't get 0 x's, which means we could then divide by the coefficient of x. Alright, 15c, we can kind of compare this one to 15a, but we'll do this one a little different. So let's look at our x values on either side of the equal sign. We need the coefficients of these x's to be the same. Now it doesn't matter what value we choose, they just need to be the same. So I can choose 3 if I want. But since this has infinite solutions, when I go to, let's even subtract something from either one, it needs to be the same thing now. So let's go and make that a 9 right there. Well now, I have a 3x, the coefficient of x's are the same on either side of the equal sign, but now we've subtracted the same thing, which will produce eventually 0x equals 0, and anything multiplied by x is, anything multiplied by 0 is 0, which will always be true. And there we go. That's a good explanation. One full sentence. Anything multiplied by 0, 0. That's very good. So you have to remember that Pythagorean theorem on this one. And for distance, of course, we're always solving for that hypotenuse. The size of a solid A is 2 times 10 to the power of negative 15. The size of solid B is 2 times 10 to the power of negative 14. The size of solid C is 2 times 10 to the power of negative 13. And the size of solid D is 2 times 10 to the power of negative 4. This is solids in size from shortest to longest. Alright, well the shortest side will be whatever, and this is kind of a magnitude problem, whatever power of 10 in these is the smallest, which in this case would be negative 15. So my shortest side would be solid A. The next smallest one would be that negative 14, which is from solid B. The next smallest is from solid C, because that's a negative 13. And then finally D has the biggest one of negative 4. That's the exponent of 10, so that would be the biggest one. It's unusual for that to come out as A, B, C, D. But it does happen from time to time. But be careful, we're looking at the shortest of these, which is going to be the biggest exponent that's negative for the shortest on these ones. If the shape EFGH is congruent to E prime, F prime, G prime, H prime, what type of transformation is represented by the two figures? We've got 3 options on this. So on this one, we only wanted one of the transformations. And yeah, let's look at the options then. So let's see, and some of you guys would put 2 different transformations on this, which would work, I suppose, as long as you explained it right. However, if I look at these ones, I can see, for example, the G's, right? It's definitely not a translation. It's not like I took this shape right here and then I just moved it over and then down, because then I can't get that other shape right there. I also would not be able to take this shape and let's say I flipped it like this. Well, even if I then translated it over here, then it's still not going to be the image. So that's not going to work either. But let's look. Let's see if a rotation will work, right? So for example, G and G prime, we didn't really go over how to find the center of rotation, if I remember right. There's a rotation of 90 degrees. So let's see if it works for the other values. Well, there's F and F prime. There's 90 degrees. And then H and then H prime, another 90 degrees. And then finally E and E prime, also 90 degrees. That looks a little sloppy, But it's the same thing as taking that and rotating it to get that other shape in one rotation. Now, I wouldn't expect you guys to do it that way, the jerks. Let me go ahead and trace this one again. I'll use a different color. There we go. So that's what I would do if I were taking a test. I would trace it on some kind of scratch paper and then see if I would have seen if the translation or reflection worked, which I've already seen that it does not. But then I would maybe, hopefully, try some kind of rotation, right? So if I take this shape and I rotate it down, it's not perfect, but it's just because my drawing sucks. But we can see that it does map onto the other shape right there. So this one is a rotation. Again, it didn't ask where the center rotation was. It's just a rotation. All right. Number 19, find the missing angle. This is from the last unit, so hopefully this one is at least slightly fresh in your mind. So I know all three angles have to add up to 180, so I'm going to take these two and add them together, 45 and 35. When I add these together, I get 80, so that would be a combination of 80 degrees. I'm going to take that 80 and subtract it from 180, because all three need to add to 180, right? And that would give me 100 degrees. So right now I'm saying x is 100 degrees, but we should check. I've got 45 plus 35 plus 100, and should this equal 180, then it is correct, and it does. That's 180 right there. Don't forget to label these on the test, because it is an angle. The two lines are parallel, not that it's going to make a difference, but angle 1 is the measure that we want, which is this angle right here. Okay, so we need this angle 1 right there, which has a relationship with that 55-degree angle. That is that these are supplementary, because they make that straight line right there. Which means I can take 180 and subtract that 55-degree angle, which would give me angle 1 at 125 degrees. Now again, you could check. 125 plus the 55 is 180, and that does work. So my answer for this one is 125 degrees. Alright guys, that does it for the lesson on this one. And just so we can see the answers for each of these, I've gone through this. It'll just show each of the slides here, or each of the pages for just a moment, so if you need to, you just pause them, and then you can copy down the answers. But remember, it's not that you should be copying down the answers. You should at least try these problems, and then compare it to what we did in class, which is right here in the video. So keep that in mind as you guys do these.